Hello my dear learners, as I have already discussed about the topic radio wave propagation, that different modes of propagation are very important in this particular topic, and basic three modes of propagation as ground wave or surface wave propagation, sky wave propagation or ionospheric propagation, and the third one is line of sight propagation or space wave propagation. So, in my last lecture I was discussing about the ground wave or surface wave propagation, and I have given the frequency based criteria to use the different modes of propagation. In this particular lecture I will focus the basic introduction of sky wave propagation and why the ionospheric region of the atmosphere is utilizing for this particular mode of propagation. So, I am just starting the lecture with the introduction of ionosphere, or why the specific region of the atmosphere has been taken for the ionospheric mode of propagation. Why? Actually, in the introductory part of radio wave propagation, I have discussed the structure of the atmosphere. That particular structure of the atmosphere which plays a very vital role in the characteristics, the behavior of the electromagnetic signals in free space. Generally, the modes of propagation are those schemes or those mechanisms or those phenomena of propagation behavior which are discriminating with each other by their use of frequency, by their use of atmospheric layers, by use of their different applications, by use of the different antennas, by use of their different polarization and orientations in the atmosphere. So, somehow all the modes of propagation are very much different to each other, and they are discriminating. The one of the most important characteristic is on the basis of the frequency range. So, when we talk about the sky wave propagation or ionospheric propagation, this sky wave propagation is limited in the frequency range of 2 megahertz to 30 megahertz. This is a very specific kind of radio band in the electromagnetic spectrum, which is utilizing the mode of propagation known as sky wave propagation or ionospheric propagation. The next point is that why this ionospheric propagation is held only in the range of ionosphere, means from the 50 kilometer to 400 kilometer from the earth's surface. So, for giving the answer of this question, we have to see the special characteristics of this particular region of ionosphere. The radiation from the space, in particular that from the sun, ionizes the gas molecules present in the atmosphere. This is the basic characteristic of that particular region in the atmosphere, which is important as far as ionization process is concerned. The ionized layer that extends from about 50 kilometers above the earth surface of the earth to 400 kilometers, which is known as the ionosphere. This is the range of ionosphere from 50 kilometer to 400 kilometer. At great heights from the surface of the earth, the intensity of ionizing radiation is very high, but there are very few molecules to be ionized. That is why above 400 kilometers, when the presence of molecules, presence of ions, presence of gaseous molecules, presence of free electrons, it is approximately nil. So, there is no any condition of ionization. When ions are not present, then ionization is also not possible at the particular heights above the 400 kilometer. As the height is decreased, atmospheric pressure increases, which implies that more molecules are present in the atoms, and when the rate of recombination is so much higher that ionization process occurs, but due to the higher rate of recombination, the ions cannot be stable on those particular heights which are below 50 kilometer. So, just because of this fact, when the molecules, the existence of molecules, existence of gaseous atoms, existence of free electrons is very much higher, but the ions which form due to the different conditions cannot be stable, and it is just because of the higher rate of recombination. When an ion forms and it becomes very soon a neutral molecule, because the recombination process occurs, and due to this recombination the ions cannot be stable. So, the existence of ions is approximately nil below the 50 kilometer from the earth surface. This is the structure of the complete atmosphere, and you can see that a particular range which is starting from 50 kilometer and reaches up to 400 kilometer is known as ionosphere. As I have already discussed about the structure of atmosphere, the lower part up to maximum 15 kilometer or 18 kilometer, or some of the places from the earth it can be reached up to 20 kilometer, it is known as the tropospheric region. The different characteristics and the properties of tropospheric region we have already studied, we have already considered, and we know that the sky wave propagation cannot be possible within the region of troposphere. For getting this ionospheric mode of propagation or sky wave propagation, any radio signal has to reach in the range of 50 to 400 kilometer for getting reflected back to the earth after the multiple refractions or reflections from the different layers of the ionosphere. This is a general concept of ionospheric mode of propagation or sky wave propagation, but step by step we will study and we will analyze this sky wave propagation or ionospheric mode of propagation. When we see the structure of this ionospheric region, when it is starting, this is the lowermost region and it is known as troposphere. Troposphere is also very important layer which is responsible for remaining two modes of propagation like ground wave or surface wave propagation, as well as space wave propagation or line of sight propagation. These two modes of propagations are happening within the range of tropospheric region. This is the stratosphere, or you can say that some of the layers are existing for the ozone layers, and within this particular region it is a very important layer of the atmosphere. But point of when we talk about the communication point of view, it is not so much important, because the two modes of propagations are happening in the tropospheric region and one mode of propagation is happening in the ionospheric region, which can be said as the highest or longest distance communication between a transmitting end and receiving end. What are the different layers in the ionospheric region? There are 4 layers in the ionospheric region. subjected to an external electric field from a radio signal, these free electrons and ions will experience a force and be pushed into motion. However, since the mass of the ions is much larger than the mass of the electrons, ionic motions are relatively small and will be ignored here. This theory is based on the processes or the operations of the radio signals which are entering into the ionospheric region for sky wave mode of propagation. How it happens? So, first of all we will study the different layers of the ionosphere. These are the 4 layers. First layer is D layer. D layer is situated between the 50 to 90 kilometer range. Then the E layer is situated between the 90 to 140 kilometer. The F1 layer which is situated between the 140 to 250 kilometer, and then last one it is known as the 250 kilometer to 400 kilometer. And this is the complete range when we talk about the 50 to 400 kilometer range in the atmosphere above the surface of the earth. All these layers are very important and play their role in the reflection of the radio signal which are coming from the earth, and when these are getting reflected from the different positions of the ionospheric layer, they are reaching to the earth at the receiving point. This is a basic phenomenon of sky wave propagation or ionospheric propagation. The ionization process in the ionospheric layer is appreciable, and the existence, the stability of these ions is appreciable only this particular region of free space or in the atmosphere. And it is just because of the fact that when the sun rays are coming from the outer atmosphere to the inner atmosphere of the earth, generally a lots of energy or lots of atoms, molecules are just flowing or moving in the different layers of the atmosphere in their different way. And the ionosphere which exists between 50 to 400 kilometer above the earth's surface is having an stable ionization. The ionizing agents presence in this particular region is very high, and as well as the atmospheric pressure is also very low. That is why at very high atmospheric pressure the simply the ionizing agents are capable to produce the ionization, and they discharge the free electrons in the atmosphere, and simply the process of this ionization occurs very frequently in the range of ionospheric region. And just because of the presence of different ionizing agents like alpha, beta, gamma, cosmic rays, ultraviolet rays, and different ionizing agents and different molecules, different gaseous components, all these at very high pressure are responsible to provide the stable ions in the ionospheric region. And due to the presence of the free electron densities on the order of 10 to the power 10 to 10 to the power 12 electrons per cubic meter are produced by ionization from the sun's rays. Layers of high densities of electrons are given special names called the D layer, E layer and F layer as shown in the previous figure. With further reduction in height through the number of molecules keeps increasing, the ionization density reduces because of the energy in the ionizing radiation has been used up or absorbed to create ions. Therefore, the ionization density has a maximum that exists neither at the surface of the earth, not at the outer periphery of the ionosphere, but somewhere in the middle between 50 to 400 kilometer. It has also been observed that the electron density profile has regions of maxima as well as regions of constant density, and these regions are known as the layers of the ionosphere. These specified D, E, F1 and F2, all these layers are specified for their highest electron density at the specific height in the different ranges of these layers. Even though D layer reflects lower frequency wave, obviously D layer is the is at the lowest height of the ionosphere. So, if we talk about the ionic density or electron density, obviously it is very much less at those particular regions, at those particular heights of the D layer. The E and F layers which are present during both day and night time. Yes, one important thing is also there, as we know that D layer is existing only during the daytime. At night its electron density is so much less that it vanishes, and it has no any consideration during the night time because it is having very less ionic density. So, this is completely vanished during night, and it has no any existence at that time. E and F layers are very stable, and as well as F1 and F2 are discriminated only because of their different ionic density, but during night this discrimination also vanishes, and just because of this discrimination is not occurred during night time. So, the F1 and F2 both the layers are being combined and form a layer which is known as F layer. So, during night only two layers exist, E and F, but during daytime 4 layers exist which is known as D, E, F1 and F2. E layer is also called as the Kennelly heaviside layer. D layer, which is present only during the daytime, does not reflect high frequency electromagnetic waves 2 to 30 megahertz, but attenuates the waves passing through it. This is a diagram which is shown for the sake of the electron density versus height of the different layers of the ionosphere, which is very important, because electron density is the most important parameter which is responsible for the sky wave propagation, for the reflection of the sky waves which are coming in the ionospheric region and getting reflected back to the earth. So, simply in this diagram what is shown, and in this diagram what is shown, first of all this diagram is for the daytime and this diagram is for the night time. During daytime all the 4 layers exist, that is why here it is shown, this is for D layer, this is for E layer, this is for F1 layer and this is for F2 layer. Height wise D layer is at lowest, E layer after that F1 and F2. Height wise the discrimination is given here 50, 100, 500, 1000. So, simply at these particular heights what will be the electron density? As we know that when we are going up in the atmosphere we are getting more electron density, and as this electron density is increasing very rapidly within the D region, this is the electron density in the E region, in the F1 region and here in the F2 region. So, here the highest electron density is approximately like up to 400 kilometer during daytime, and during night only 2 layers exist, D and here this is the D, E, F1 and F2. When we combine it, then it shows only the variation in 2 categories which are known as E layer and F layer. So, simply at the different heights we can consider the electron density at two particular layers only. So, during daytime these 4 layers exist, during night time only 2 layers exist, and the electron density is increasing as the height is increased. Along with the E layer there exists the ES layer, and I have already told about the different layers of the ionospheric region. The different characteristics and the different properties of these layers is summarized here like this. As characteristics of D layer, it is the lowermost layer of the ionosphere, which is situated at the height from 50 kilometer to 90 kilometer from the earth surface. Its thickness is about 40 kilometer. It exists only during daytime and disappears at night time. Its ionization properties depend on the altitude and sun above the horizon. It is not useful for high frequency communication. It reflects some of the VLF and LF wave. It absorbs medium frequency and high frequency waves to some extent. The critical frequency is approximately 100 kilohertz, and its electron density is approximately 10 to the power 8 to 10 to the power 9 electrons per meter cube. Characteristics of the E layer, because it is upper layer from the D layer. So, it is having the more frequency range which can be reflected back from the reflection from the E layer. That is why it exists next to the D layer and at average height of 100 kilometer from the earth surface. Its thickness is about 25 kilometer, and high frequency waves can be reflected from the E layer during daytime. Its electron density is 5 into 10 to the power 5 electrons per cc, and its critical frequency is approximately 4 megahertz. ES layer is the sporadic E layer, and its appearance is sporadic in nature, which exists in both during daytime and night time. It is a thin layer and its ionization density is high, and it appears close to the E layer, very close to the E layer, which appears and it provides good receptions. The characteristics of F1 layer, it exists at height of approximately 180 kilometer during daytime, and its thickness is about 20 kilometer. It combines with F2 layer during night, and high frequency waves are reflected to some extent, which absorb high frequencies to a considerable extent. It passes on some high frequency waves towards F2 layer, which is having a critical frequency of 5 megahertz. The highest layer which is existing at the highest level in the ionospheric region is known as the F2 layer, which is the most important layer for high frequency communication, and its average height is about 325 kilometer during daytime. Its thickness is about 200 kilometer. It falls to a height of 300 kilometer at night, and it combines with the F1 layer. Obviously, during daytime the ionic density is lowered and reduces to lower heights. That is why the existence of the different heights for the different layers are coming down. That is why the existence of F2 layer during night is approximately 300 kilometer, and the different electron density and critical frequency are given in the for the F2 layer are mentioned here. So, this was the structure of ionospheric region, and it was very important as far as sky wave propagation or ionospheric mode of propagation is concerned. Without knowing the different characteristics and the properties of the ionospheric layer, the different layers of the ionosphere, we cannot study well the ionospheric or sky mode of propagation. So, thank you very much for watching this video. In my next video, I will discuss the different properties of sky wave propagation and the different parameters which are being used in the operation of sky wave or ionospheric propagation. Thank you very much.